Alright, coming back to this function, we have now the graph drawn, the domain and range stated. We need to identify x and y intercepts, meaning where it is crossing the x and y axis, respectively. So take a look at the y-intercept first, probably. That's usually where we start with lines anyway. It is defined here because of the blue function. So because of that blue function, we can say it has a y-intercept at y equals -1. If it had just been the red function here with its open circle, we would not have counted it. So if the red function had had an open circle here and the blue function had been defined up here somewhere, we would not have included -1 as a y-intercept because it was not included in the restriction up here. In terms of the x-intercept, it is crossing the x-axis as well. Since our slope here was up 3/1, then in terms of going up 1, it would have only gone over 1/3. Okay, and the last feature of the graph we want to talk about is something called continuity, meaning that if I start my pencil off on the beginning of the graph and I move along all of the pieces, can I make it to the very end without having to hop over a hole or jump across a gap like in this function where the pieces were not connected. So is this function connected without any gaps in the middle? And the answer is yes. So you would say that yes, that is a continuous function. Notice that this also does fit our definition of what a function is, as most of these ones that we will look at here will, in terms of it passes the vertical line test, meaning that if I drew a vertical line anywhere on the function, it would in fact pass through no more than one point. Okay, now if you still have some trouble with this and would like a source to check your work, you can use Desmos.com. Now I know you may be getting tired of me using this. We'll use it quite a bit second semester, but it is a good resource for graphing. You can use, of course, your graphing calculator just to check the shape of the graph and where it's going. But as you can see, I've got the dinosaur of the Time Warner cable fail where my internet is not working at the time. I will try and do a separate video and post that up before you all have class because you all are at the end of the day, so that if you want a computer resource to verify that your functions are drawn correctly, that you will have that available to you. Okay, so just check back onto SchoolFusion. There should be a video there by the time you are watching this that will help you to verify your function. Let's go on to the next hand-drawn example. So f of x is defined as x squared minus 1 if x is less than 0, and 3x plus 2 if x is greater than 0. So the first thing we're going to want to do is to draw it. So I'm going to use the T-chart method because in the past that is the way that people have typically preferred. If you want to rely on your knowledge of parabolas and lines to draw it and erase the parts that you don't need, you are welcome to do so. So first function, it just says less than 0, so I will pick 0, so I know where my open circle goes, and a couple of values less than 0, make them kind of nice and small so it's not difficult to calculate easily. With the second function, it's greater than 0, so I'm going to pick 0 and a couple numbers close to but larger than 0, and work out the math. Okay, so I've worked out my T-chart values. To start off with, for my parabola, I have 0, -1 as a point. I have, I did that in reverse order, -1, 0 as well, and I have -2, 3. Okay, because it is just less than 0, I should have made, I will go back and change that to an open circle on y-axis, and then draw the half of the parabola that represents. And for my my line, 3x plus 2, it has a y-intercept of 2. This time I'm catching on to the fact that or remembering, I should say, that I need to make that an open circle. And then 1, 5, and 2, 8. And there should be a difference in the shape when I draw it between the parabola, which should be more curved, and the line. Although I understand drawing on a tablet, obviously I'm having the same difficulty. They don't always look the way that they should. Okay, for domain and range. Now that we have the graph, for domain, I see that I have arrows pointing. The red function, the first function, is pointing, going on and on forever in the negative infinity direction. The blue function is pointing on and on forever in the positive infinity direction. The only x that is not included is right here at 0, because 0 is not included in either one of these functions. So you can either put x cannot equal 0, implying that it could be anything else, or the way that the book would put it would list it as two separate intervals between negative infinity and 0, but not including 0, and either and or the union symbol 0 to positive infinity as our domain. Now the range, they're both heading towards positive infinity on the y. The lowest y value that it has is -1, and that is not including -1 because of the restrictions. So you would say between -1, positive infinity, both with parentheses for the range. Now on this one, although it has lots of interaction with the y-axis, you may think, both of these are open circles. So this one actually will have no y-intercept because neither one of those circles are included. And then the x-intercept would be where the red function intersects it. The blue function does not because of where it's been cut off. Is x-intercept at -1. And then is this continuous? You would say no, because if I start on the red function and tried to trace the entire piecewise, so that's everything together, there's no way that I could go from one function to another without jumping over a large gap. So this would be it would be a function, but it would not be a continuous function. Okay, the last two examples, just ones with have kind of special cases, I suppose, where I have one that does not have an x in it, for instance. If it is just defined at a single x value, then what this is going to be is a point. There we go. Compared to if you have this one, where it has the same y value, but it's given at a range, then it's going to be just a horizontal line. Okay, so I left everything else the same on those two examples. Let's see what those look like. So I will use red for this first function. So it has x less than -1. And on these two, I'm just going to focus on the graph mainly. So -1, -2, -3. Blue function. Nope. Blue function. Greater than -1, so -1, 0, 1. Do the math here. So -1 plus 1 would be 2. One color again. 2, 3. Put those points on here. So -1, 2. Not including it would be open circle. -2, 3. -3, 4. And it would get an arrow because it's going on and on forever. There's not another boundary here. Drawing in the blue now. I have -1, 1. Also not included. 0, 0. 1, 1. It's a parabola and should look like 1. And then this middle piece that I have identified as a point, let's go back to black since that's how I wrote it, is just the point -1, +2. So -1, +2. That point fills in the open circle on the red function, but still it would not be continuous because it doesn't connect with the other function at all. Okay, so there would be your point represented by y equals 2 if x equals -1. Okay, let's take what we just did. Come on, arrow. There we go. And I'm going to scoot this, copy it, clone it, move it down because I think I kept very similar functions here. Save myself a little bit of time. Okay, so red function is less than -1. That has stayed the same. The blue function I will need to adjust a little bit because that is now greater than 1, then +1. Okay, so 1, 2, 3, 4, 9. Okay, so plot the blue function here. 1, 1, where 1 is not included. 2, 4, and 3, 9. And that should look like the side of a parabola. Then the other function, 1, 2, 2, 4, look like a line. And then in between there, to draw this, between -1 and +1, it's a horizontal line at 2. So this should be open circle. And then the black function fills in between -1 and +1 as a horizontal line. Okay, so once again, it does fill in the open circle at the red function, but not quite continuous because of the gap between the black and the blue. Okay, last bit for today is taking a look at writing the equation. Now, if you're feeling kind of overwhelmed because we have done a ton this chapter, please do not stress over this, but I just wanted to expose you to this so you're aware of this, have seen the skill, because we will be writing equations for various instances throughout the rest of the year. So if I have something that looks like this, where I have a piecewise function given to me and I need to write my equations, I need to be able to work backwards to come up with the equations that fit it. So for instance, I would start off with this parabola. Parabola centered at the origin, so it has a point 0, 0. Pen has 0.00. I can also see it has the 0.11 and 24. Well, that is the equation of y equals x squared. And it looks like it is defined everywhere less than -2. So it has an open circle at at +2, and it is going on and on forever towards the negative infinity direction. So it would be if x is less than 2. This single point right here in the middle has a value of y equals 6 if x equals 2. So in the reverse of the second to last one we just did, where I have just a single point. And then this last one, that is incorrect, don't pay attention to that. This last one is a line, so I can tell it's going to be a slope-intercept form. And I need to figure out what the value of this is. So I can tell it's going between 2, but not including it, and 6. And all I would need to do is find the coordinates, for instance, of 2 of the points, and do the slope formula, and find the equation of the line between those two points, and I would end up with -x plus 10, x squared, and y equals 6. I hope this helps in terms of everything and more than you ever wanted to know about piecewise function. There is a practice worksheet that your sub is going to instruct you to do, and please let me know if you have any questions or need some additional assistance. There I have lots and lots of practice that I can provide for this. See you soon.